Hello and welcome to Friday's edition of Cracking the Cryptic, where we're going to be taking a look at a beautiful puzzle today called Ocean Spray by Florian Wortmann. Florian has appeared on the channel many times, always with wonderful puzzles, and this one, well, it's going to be wonderful. It's got a sort of 95% approval rating and is about 3.5 stars apparently for difficulty, so maybe a little bit more difficult than yesterday's puzzle, but it shouldn't be monstrous. And we'll have a look at this. These are region sum lines, and it's an incredibly short rule set today. Just 2 sentences and a new sentence describing the region sum line rule, which I have to say feels like a very natural sentence to me. Anyway, I'll read the rules in a moment or two's time. A few things to mention. There's a crossword video on the channel today. Thanks to Mark for taking over the reins today when I had to play in a golf match, which was unsuccessful. Well done, Matt. Bar humbug. Anyway, so Mark, what you can watch Mark solve if you're interested in improving your cryptic crossword solving, certainly recommend that. And then other things going on. I want to say congratulations to Suzette, who sent us an email saying she's been watching the channel for a while and trying to pick up tips about improving on Sudoku, and recently went on a cruise through Mexico with her family and took part in some Sudoku competitions that they had on the cruise, and beat everybody, won twice, including beating all her siblings, and she's the youngest. So that was apparently a great source of pride. So well done to Suzette, and I'm delighted to hear that we've made a positive difference to your Sudoku solving skills. Other shout out goes to a few of you have spotted this, but yesterday we got tweeted this from Bevo Bexley, who noticed that Mark's video and my video yesterday both ran for the identical length of time of 51 minutes 49 seconds, which was obviously a complete accident. I don't know how many times that's happened before. I'm guessing probably, well, there have been thousands of videos now. So when did we start doing 2 videos a day? The start of COVID. Yeah, so that's quite a while ago. It probably has happened, but yeah, it might not have done. I don't know if anyone out there wants to take on the challenge of figuring that out, but well done to all those of you who spotted it. And the only other thing I would like to do is to wish a couple of people a very happy birthday. Daniel, over there in Germany, I think near Munich, you have turned 47 today, and I know this because your partner Stephanie wrote to us and said you'd appreciate a shout out. Apparently I ought to be able to hear you shouting at me sometimes when I fail to do Sudoku. And I'm not sure whether you're going to get chocolate cake today, because I understand you're on the road, but I hope you're able to find a slice or two and it is suitably iced. So happy birthday, Daniel. And then also a happy birthday to Felix, who's turned 28 today. And I know this because your friend Emmy wrote to us and said you might appreciate a shout out, and she wanted to thank you for getting her hooked on cryptic crosswords. And apparently, Felix, you are a brilliant puzzler, which I'm delighted to hear. So many happy returns. Now, let's get on with some Sudoku solving. Let's see what Florian Wortmann has in store for us. This puzzle, Ocean Spray, has the following rules. 1 given digit as well. Normal Sudoku rules apply, so we have to put the digits 1 to 9. Once each in every row, in every column, and in every 3x3 box. And then box borders divide each blue line into segments with the same sum. Isn't that a gorgeous way of describing the region sum line rule? So what does that mean? Well, that means that let's try and work out what this line is. So those 3 digits there, you can see this line sort of travels along until these 2 box borders, I suppose, divide it from box 5. So those 3 and then those 3. Each colour there, the sum of green would be equal to the sum of purple, would be equal to the sum of yellow. Let's try another one. Let's try this one. So that one would be the sum of those 2. Let's use grey. Okay, and that one there, I think that would have to be red again, look. Because we know that these have the same sum. So those 2 digits ought to be the same by that logic. And then those 3 digits would also, let's make those blue. So the sum of blue would equal red, would equal the sum of grey, would equal red again. Do have a go. The way to play is to click the link under the video as usual, as Maverick is about to fly past. But now I get to play Let's Get Cracking. And we've got an absolute density of blue lines going through this middle box, haven't we? It's completely... Oh, actually, no. Box 6 is also completely covered. Oh, no, actually, loads of the boxes are completely covered. I was wondering whether we were going to be doing some sort of 45 maths, 45 being the secret that I share with only my favourite people. And of course 45 is the sum of any complete Sudoku box, any complete row or any complete column of a Sudoku, because by the rules of Sudoku you have to put the digits 1 to 9 once each into those things, and 1 to 9 add to 45. So... Well, actually, I might go back to this line, actually, because this line seemed to me to be quite interesting in the sense that those 2 digits there are definitely the same by the rules of the puzzle, but they also have to be a little bit high, because these 3 digits here have to sum to the same number as orange. Now, even if these were as low as we could possibly make them, they would be 1, 2 and 3. 1, 2 and 3 add up to 6. So orange is at least a 6. Yeah, what about that one? Okay, so that one is definitely not orange by Sudoku, because these are in the same column. And this one is also the sum of 3 different digits, so that is at least 6. Yeah, that's much less useful. The sum of 2 cells equaling the sum of 3 cells is less good, isn't it? No, hang on. This line here also has... Yeah, what you're often looking for with these so-called region sum lines is strings of bits of line, which might be, for example, here we've got 1 digit in box 1, but 3 digits in box 5. So again, we can pull this same trick. Well... Oh, bobbins. Or blobbins. That's what we should use today, isn't it? After discovering the blobbles in yesterday's puzzle. Blobbins! Because that digit is the same as that digit, I've suddenly noticed. But this digit could well be orange. Or yellow. So we know that orange and yellow are different, but we don't know that purple is different from either of those things. But purple is another of these digits that has to be at least 6, because these 3 digits have all got to be different. Yeah, this is going to get complicated if it stays this tricky, actually. Okay, we've got another one there, I think. Oh, we've got another 2, actually, I've just spotted. Okay, so this cell is also the sum of 3 different digits. So that digit, let's make that green, that's at least 6 again. And that's definitely different from orange, but might not be different from yellow, and might not be different from purple. And then on this line, the top, well, almost the top line, if we ignore that one, this square here is the sum of those 3 digits. So again, that's a big digit. Let's make it grey. Hang on, right. So I always ignore given digits. I get them so rarely. But there's a 7 there. So these 2 are... Well, one of these is definitely high now, like 8 or 9. I was about to say that grey was different from purple. That is the most... Yes, it is true. And, yeah, Daniel will be shouting at me all the way from Munich about that, quite rightly. But the problem we've got here is that how many different colours have I now? I've now got 5 different colours, so there must be some of these colours must merge together, because 6, 7, 8 and 9 are only 4 different digits. So how are we going to do that? No, nearly, very nearly. Yeah. Okay, let's get rid of 7 from that, but also we can ask where purple goes in this box. Now, there's a trick we can do with region sum lines. So by Sudoku, we can see purple is in none of these cells. That's very clear. But could we put purple in on either of these two squares? And the answer is no, because if we did put purple there, what would we put into the other cell on the line? That would have to be a 0 by maths to make sure this line segment added to the same as this line segment. And we can't put 0 in Sudoku, at least not in this Sudoku. So we're now close to proving that purple and orange are the same digit, I think. Because one of those, purple goes in one of those. Oh, this is already getting quite tricky. So purple is in one of those, and again, purple could be the same as green. Ooh. Yeah, and then we can repeat that trick. Look, where is orange in this box? And orange, by Sudoku, is not in those squares, and by this idea that you can't have orange on this line because this would be a 0, it's not on this in this domino. So orange is in one of those two squares, again suggesting it's got a lot in common with purple. All I need to do is to get orange and purple in the same cell. How am I going to do that? I don't know. Or there has to be some. I do have to be able to get some. At least one of these colours needs to disappear and become another. Golly gosh, I'm so sorry. I cannot see how to do this at all. Ah! Oh dear, oh dear. What on earth am I meant to do here? I'm just having a total brain freeze. What? Oh, hang on. Okay, where's yellow in this box? Yellow can't go in its own row or on its own line because these can't be 2 zeros on the line with it. And yellow is different from orange. So yellow is in a domino in box 8, which means yellow is in a triomino in box 9. See, if... Oh, I just... I'm not sure. I'm not even sure how I'm meant to think about this. Is it something to do with... Ah, yes, okay. So these two digits together, maybe this is what we're meant to do. But they could be the... Oh, they could be the same. No. Well, yes. Okay, all I'm noticing is that those two digits there, I'll just circle them to make it clear what I'm talking about. Those two digits, they are clearly the sum, aren't they, of that domino and this triomino. So they're the sum of 5 different digits in box 6. Now the minimum I could put into these squares is 1, 2, 3, 4, and 5. So that means that these two squares add up to at least 15. But I don't really know how to use that either. When I say I don't really know, I don't know at all. These add up to at least 15, so these add up to at least 15. And they go, okay, and they go off wandering into this box. So that, okay, is that doing something then? So the sum of those 5 digits is the same as the sum of those 5 digits. Oh, no, no, that's actually, it's also the same as the sum of those 5 digits. So maybe, no, they don't. I was wondering whether that was going to do, something useful. But I don't think it does. I mean, it may be doing it, and maybe Daniel may be shouting at me again. Or Felix might be. Felix is a brilliant puzzler. That's what Emmy told us. I wish I was being a brilliant puzzler today, but I can't see. I really can't see. I mean, I know the idea. The idea must be to somehow get these colours joined together. I just can't see how to do it. So orange. Orange is on this line, but we don't know whether purple is or not. There must be some configuration here that's problematic. Is it actually possible for orange and purple to be the same digit? That would mean, what would that mean? This would be that digit, that they would all go, so that wouldn't be this digit, so it'd be in one of those two. I'm sort of expecting Sudoku to help me out there, but it just doesn't seem to be doing it. There's 3 digits. Bobbins, I don't know. I don't know what to do. Okay. What about that one? Is that doing... So this digit can't go on its own line. Now if it's up here... No, this line up here is horrible, isn't it? 3 versus 2, that's not doing anything. Okay. God, Bennett. Okay, right. Wow. Okay. All right. I've not proved what I thought I was going to prove. I've proved something different. All right, but I've still proved something. Right. Okay. What we need to do, believe it or not, is not look at these cells at all. I need to look at this line wiggling its way through the grid, because let me just how should we do this? Let's use the line tool again. Right, so we can see that line segment there adds up to the same as that line segment, and it also adds up to the same as that line segment, but I'm not going to worry about that for a moment. I want to compare the overall contents of this box with the overall contents of this box and see what we can see. Now, we can see that red is definitely... We could cancel those out, couldn't we? So if we're trying to work out the maths of this box versus the maths of this box, red appears in both, so we can take that out. Now, what else appears in both? Well, purple appears in this square, in box 1, and purple is the same as the sum of those 3 cells in box thingy down there. Box 5 being the technical term. Now, but we can do the same with this square, which was my green square. So that cell is the same sum as these 3 digits. So what we're left with, let's use a different colour for this. This is an important choice. I don't know what to make it. Blue. I've not used blue, actually. I'll use blue. So what we're left with is a proof that says that these 2 digits are the same value as these 2 digits. But I know that these 2 digits are orange, and I know that these 2 digits, look, are grey. So orange and grey are the same. And that, the reason I think that's important, if orange and grey are the same, and they are, I'm going to change grey to being orange. I've now proved that orange and purple are not the same. And that is presumably going to do something. So orange and purple are not the same. They're not allowed to live in the same cell. So that cell is orange now, not purple. So purple is moved across into this square. So that is 6, 8 or 9. I don't know, that felt quite difficult. I didn't see that. How long did that take me? Ages to see that. We might be able to pull similar types of tricks actually. Again, but let me mull this over. What else does this mean now? So purple is now in one of these 3 squares. That's just so... is there a reason that purple can't overlap with yellow? Do I know anything about yellow? I know yellow is not the same as orange. I don't know. Maybe I am meant to know something there, but I don't seem to know it. Ah, where is orange in this box? It can't repeat on its own line. So orange is down here. Now orange and yellow, I know that they are different. So that's almost getting interesting. But I don't know that yellow is different from purple. Okay, maybe I can do... Ah, yeah, hang on. Where is orange in this box? Orange is not in those squares by Sudoku, and it can't go on its own line, look. So orange is down here. Oh, which I could have got that ages ago, maybe. Purple can't go on its own line. And if purple goes on... Well, that's marginally interesting. Yeah, I see. Okay. We can use... This is a trick I've seen before. Look at those squares for a moment. Now, what would happen if purple appeared in one of these grey squares? We can see that these grey squares mathematically are the sum of orange and purple. So if purple appears, say, here, that means that the remaining 4 cells must add up to orange, but the triangular number for 4, if we made these cells then as low as we could with 1, 2, 3 and 4, they would add up to 10, and that square cannot be a 10. So purple actually doesn't go in the grey squares here. So purple, which can't go on its own line, can't go in grey at all. Purple is locked into these squares with orange. Now, that doesn't mean that there isn't yellow, because if yellow and purple were the same, I mean, what we can say for sure is that this is an orange-purple pair. But what we don't, I'm going to take out that yellow, because yellow could well be overlapping here. I just don't know. If yellow and purple are the same, then yellow is over here. But I do know that these are definitely orange and purple. So they're definitely from 6, 8 and 9, actually. And the... Oh, no, that's not even true, what I was about to say. So... got it. Right. we're there. We're there. Right, where is 7 in this box? Don't know is the short answer, but it's definitely on one of the lines. Now, these grey cells here can't add up to more than 17, because even if I made these two squares an 8-9 pair, they would only add up to 17. They're not the same digits. We can't double 9 them. We have proved. It took us a long time, but we did prove that orange and purple were different. So now this has to be 1, 2, 3, 4, 7. This is a 5, 6 pair. That's not 7 by Sudoku. And because these have to add up to at least 17, they have to be 8, 9. So everywhere that we've pencil marked, orange or purple, we're allowed to change it to an 8, 9 pair. And that might mean something good. Maybe. I don't know. Sorry, I can't see it. Oh goodness me, this is appalling. Sorry, I just can't see. I can't see what I'm meant to do here. Oh, it's so frustrating. At least I made a little bit of progress just now, but then I've just absolutely stalled. So this digit, do I really think that's going to be, if that's purple again, then these squares add up to 17. But I don't know whether they'd include 7 or not. Is that right? Yeah, okay. Where's the 7 in this congregation of digits? It can't go on the 3-cell line, can it? Because even if we add 1 and 2 to it, we'll get to 10, and that's definitely not a 10. So 7 is in this domino, and if 7's in this domino, it's accompanied by 1 or 2. Right, that makes sense, because if this is 1, 7, the minimum that line can be is 2, 3, 4, adding to 9. And vice versa. If that's 2, 7, this has to be 1, 3, 4. And this would then add up to 8. So 7 is now in these two squares. This is a minimum. And these are a minimum of 15. And right, okay, so maybe is that a problem? If that's 1, 2, 3, 4, 5, what do we have left? 6, 7, 8. Ah, that won't work. That's not 6. That is not 6. Because if this was 6, I don't think that cell's got any legitimate fill. I might be wrong about that, but if you look at this column, all the high digits have gone. In fact, I might as well pencil mark it. All of these digits are from 1, 2, 3, and 4, aren't they? So if I force this collection of digits here to include 1, 2, 3, and 4, I'm going to break this square. So right, so that's definitely not 6. If it's 7, then this would still include 1, 2. If this is 7, this is either 8, which we know breaks because 15 can't work here, or it's 9, and this would be 16. But the only way of making 16 in 5 different digits is 1, 2, 3, 4, 6, and that's still going to break that square. Okay, so now we've done it. Now we've done it. This square is an 8 or a 9, and it's not orange by Sudoku. So that is, in fact, therefore purple, and that means these squares are not purple. So these add up to 17, and those add up to 7. So we've got a total symmetry. I suppose it's not very surprising, given how our ocean tide is moving. But these squares are 17. Now, do we know where the 7 is this time? Because the 7 was very useful down here, but the 7 here can be in any of those 6 cells, I think. Right, I see. Okay, so how are we going to make this total work? We know these add up to 17. There are only 2 ways of making 17 in 5 different digits. It's either 1, 2, 3, 4, 7, or it's 1, 2, 3, 5, 6. They are the only 2 ways of doing it. Either way, it's always got 1, 2, and 3 in it. So that square is a 4. This square is not a 4. That square is not a 4. That square is not a 4. And that's going to be very useful for the following reason. Come on, brain. Think of the reason. Naughty brain. Naughty brain. Oh, this is so frustrating. I think I am close to figuring this out now. I just can't see it. Do I now know more than I used to about anything? I got this 4. I thought that would be at least... Oh, yeah, okay. No, that is useful. Because this now can't be 1, 2, 3, 4, 7, can it? So it's sort of Sudoku. Oh, Daniel's definitely going to have been shouting at me. It's sort of Sudoku now on this box. These squares cannot be 1, 2, 3, 4, 7. So they must be 1, 2, 3, 5, 6. Right. And do we now know what this is? Absolutely not. Okay, so these squares are from 7, 8, 9. So 7... Oh, well, maybe, no, yeah, oh, this is cute, I can do this, right, where is 7 in this box is the question I'm going to ask. Now 7 is not in those 3 squares by Sudoku, and 7 can't go on a 3-cell line that adds up to a single digit total. We've already looked at that because it would be 7, 1, 2 at least. 7 plus 1 plus 2 is 10. So the 7 is not in those squares. So the 7 is on this line. And now look at look, if I extend my red line, it's perhaps easier to see. But this line segment and this line segment, which add up to the same total, they both include an orange and they both include a 7. So the other digit must be the same digit, mustn't it? Which is 4. And if 4 is therefore on this line, 4 must be in this domino along with orange. So this is a 4 orange pair. And we know how to pencil mark that. It's a 4 orange pair. What's orange? Orange is 8 or 9. So that is a 7 by Sudoku. Or, well, sort of, I don't know, is that by Sudoku? It's by lunacy. And it's a 7 by lunacy. And 7 is therefore nearly, well, could it be on the line here? It would have to be with a 1 or a 2. Maybe. Maybe it can be, I'm not sure. And these squares... Oh, so these squares are the same as those squares. They're 1, 2, 3, 5, and 6. So these lines... Oh, that makes total sense. Because, yeah, we've just got the inversion, haven't we? We've got 17 there. So we know those added up to 17. Now, I'm sure that there are different ways to do this that would be more efficient than the way I'm finding how to do it. But... Yes. Okay. Yeah, so we can go back to what we did earlier. we worked out those squares were the same total as those squares, were the same total as these squares, and now we know that they are all 17s. So they've always, this has got 1, 2, 3 in it, and this has got 1, 2, 3 in it. That's probably worth recording. But we don't know, do we, about 7? Or do we? Where's orange in this box? Do we know that? Orange can't go on its own line. Can orange go? Orange can go on red, it very much can. But can orange go on this other line? No. Yeah, that's it. That's it. Literally, orange has only got one place in box 1. Because this 3-cell line is adding up to a single-digit total again. That could well have been available for ages. I just didn't see it. So in fact, orange only gets to go in that square. So that is orange, which means, yes, I get orange exactly placed in box 7. This square can't be purple, I've only just realised. So we are within a whisker of proving that yellow is purple. Oh, yeah, it's easy. Okay, it's easy. How on earth would this square be an 8 or a 9 and be purple? Because then we have to add something to purple. So that would make purple have to be 8. It would have to be 8 plus 1 equals 9, which would have to be orange, and it can't be, because orange is there. So that can't be purple, and after all this time we prove that yellow is purple. Yellow is purple. So that means that square is 8 or 9, which means these square, yellow just disappears from the puzzle. There is purple in one of these. Now, can we get purple up here? Yes, we can't put, well, nearly. Purple can't go on a 3-cell line adding up to orange, so purple is up here. So purple is in one of these squares. Can purple go here? And the answer is, I don't know. I don't know. Orange is in one of those squares as well, I've just noticed. 7. Not quite. I can't quite see how to do that. Right, but things are slowly becoming clearer, I think. That's probably famous last words, but I know these squares. I mean, I don't want to pencil mark them, but they are 1, 2, 3, 5 and 6. Okay. I mean, I know you're shouting at me now, everybody, because it must be obvious what I have to do now. I'm so sorry, I just can't see it. Does it? I would like to know which one of these is orange. I think I'd have to do that there. I've got 4, 8 and 9. So these are from... These are from 1, 2, 3. No, they include 7 as well. I was suddenly thinking that I've not got enough digits in row 4. Is it? I think what I need to do. I know I've got orange on this line. Well, okay. I don't know how to do this. I know this domino adds up to 11, don't I? Because if we look at the structure of the red line in every line segment includes an orange, And the other two digits are 4 and 7 in these two boxes. And 4 and 7 add up to 11. So these add up to 11, which means they're either 4, 7 or they're 5, 6. And one would think that one could know the answer to which of those is correct. One would think that, but I don't actually know it. Yeah, I mean, it's just the corollary of these adding up to 17, isn't it, as well? It's not, I haven't actually taken the sum knowledge, the sum of knowledge forward at all there. I haven't done what GDC did yesterday by basically infusing the world with thousands of hours of joy by creating a puzzle. I've actually done absolutely diddly squat by getting that deduction. Do I know there's a 4 here? I do. So I do know there's a 4 in one of those squares. Right. So I'm so sorry, I'm stuck here. I can't see, no, I mean there's a small thing I can see here where I've got 2 cells adding to purple, and I've only got 1 cell adding to purple here. So these 2 digits sum to one of these digits, but I mean, how I'm meant to use that, I've no idea. Do we know? Do I know which of those is orange? Do I know which of these is orange? How is this ever going to resolve? No, I don't know there's 7 on this line, so I can't assume that this is like that. I know one of these is 1 or 2. I don't know that one of these is 1 or 2. Unless I can force the 7 onto the line segment. This purple, I mean, if it's 8, there has to be 1 down here. 7 is there. Does that do something? Yeah, okay, tiny thing. Where is 7 in box 8? It's not here by Sudoku, it's not here by Sudoku, and it can't go on a 3-cell line that adds to a single digit total. So 7 is in one of 2 places. So 7 is in one of 3 absolutely hopeless places. Can that be 7? These 2 squares would add up to 7. It looks fine, doesn't it? Doesn't look too difficult. Bobbins. What about? I don't even know how to think about this. What do I know about this line? These 2 digits. These 3 digits. Oh no, that's sorry. I miscounted the line. I thought I'd got something here, but I don't have it. That's just the same deduction we had last time. Oh, okay, right. I have got it now. Oh, that's really. God, that's not easy, but it's very beautiful. Okay, I think I would have got this more quickly actually if I pencil marked this box. So maybe that is a lesson for me there. Okay, this square is not 9, and that's because if this square is 9, that square is 9. Now, actually, we did this yesterday, and some of you liked it, so I will repeat it. But if you want to consider why that doesn't work, pause the video, and if you haven't seen it yet, I know lots of you will have seen it, but I hadn't seen it until about 12 seconds ago. The reason I'm going to tell you the answer now. If you did get it, congratulations. The reason that these can't be 9 is that there aren't 2 different ways of making 9 from these digits. So, I mean, maybe this is the way to do it. If I pencil mark these with the same digits, now you can see, if this combination and this combination are the same, we have to put those digits in row 5 somewhere, and they've only got one cell to go in, which is this one. So this cannot be the same combination. So imagine this was 9. How do we make this work? We don't have 4 and 5 available as an option, so there's only one option, which is 3 and 6, and there's only one option, which is 3 and 6. So this would be a Schrödinger cell. It would have to simultaneously be 3 and 6. That won't work. So in fact, we've now made real progress, because orange is 8. Now, I can't double click them, I don't think, because I've got so many cells highlighted that are 1 of 2, but we can do it slowly. We can do it this way. So these are all 9. This is great. Look, down here, all of a sudden, this must be a 2 and a 7, which means 2 comes off this line. So this becomes 1, 3, 4. And now we still have the same consideration to bear in mind, which is that these, well, this domino in particular, let's make it red, has to be different from this domino. So we know now that we can't have 1s in here because we're adding to 8. It's either a 2-6 pair or a 3-5 pair, and this is the opposite version to make sure that we don't have a problem in this square. Now, what else does that mean? No, what I was about to say was total and utter nonsense, so I'm not going to say that. So these are adding up to 9. They've definitely got 1 involved in them. Oh, come on. I mean, this definitely does something. I just have to figure out what. Come on, Simon. What does this mean? I'm just not seeing it. I'm not seeing it again. I don't believe it. I don't believe it. I'm going to go full Victor Meldrew. Right. This is an 8, a 3. What is in effect a 3-cell 8 arrow? Those 3 digits have to add up to 8. So they're either 1, 2, 5 or 1, 3, 4. And I feel like I should know which of those is likely to be correct, but I don't think that I do. And these 2 digits are adding up to 9. And they're not 1, 8, are they? Yeah, they're going to use either the 2 or the 3 that I know must be in these cells, and that can't both go on the putative 8 segment. So this is either 2, 7 or 3, 6. And then what does that mean? So these squares are. I'm actually going to go full pencil mark here. I'm just not. I think it's that. I don't know what it is. Actually, I don't have a good excuse. But I can't seem to make these wavy lines permeate my brain in a way that's in any way helpful. It's incredibly irritating. Okay. So what do we do now? This is a 9 arrow. So this is either 1, 2, 6 or 1, 3, 5. It can't involve a 4. But I don't think I know which. I almost feel like I have to work harder with the 4s here, because I'm really struggling to see how to move this forward. I did get a 2-7 pair down there. Is that something I haven't thought about properly yet? I know these are 7, 8, 9. No, okay, I'm stuck again. I know there's a 4 in one of those squares. Is that useful? Doubt it. Can I put 4 on here? Can I put 4 on there? Oh, if I put 4 on there, these would have to be a 1-3 pair. Does that work? It might do. I can't immediately see why not. And if I put 4 on here, adding up to 9, this has to be 2, 3, 4. I mean that still does work. Bother. Wow, this is as much trouble as I've had with a puzzle in a while. 51 minutes. I don't mean that I've taken ages on it. I mean that the Jesper Josephson one I did the other day for you guys over on Patreon, that was 2 hours. But I never felt during that I was absolutely stuck for ages, and I keep feeling I'm absolutely stuck on this one. Oh, is this an 8-9 pair now? Yeah, that's been an 8-9 pair forever, hasn't it? Ah, okay, well maybe that does something. Does that help me? How does that help me? So these squares, yeah, that does help me. Oh no, is that literally that simple? Oh, forgive me. That's awful. Okay, well I've unstuck myself, because if this is an 8-9 pair, 7 has to be in this little congregation of digits. And if 7 is in this congregation and they add up to 17, then we know what the exact formulation is. They are 1, 2, 3, 4 and 7, and this is a 5, 6 pair. And now this is not a 5 or a 6, which is presumably going to do something. He says, wow, this is an 8 arrow, so it definitely can't include 7. So there's a 7 here. So this is either 1. Oh no, well in fact it's because the 7 is here and it's adding up to 9. We know what it is. This is 2, 7. Right. So this is not 4. Oh, what did we I thought these were adding up to 11, weren't they? So they're not 4, 7 now. That's 5, 6. This arrow does not have 2 on it. So this is 1, 3, 4. And in this row, these two squares are from 1, 3 and 4. And now 13. Okay, now we can prove this is purple, I think. Yeah, because the only way that this is not purple is if I make this 4 and this 3 and make this 6, because the minimum sum of these two squares is 8 and 5, which is 13. So if I max this out, that allows this to be a 6. If it's not 6, it's got to be higher than 6. And it can't be 7 or 8, so it would be 9. Now, can this be 6? Well, the only way this could be 6 is by making that 8, 5, but that makes this a 6 as well. So that's not going to work. So this is in fact therefore purple, and therefore it is 9. And if it's 9, this square is 9 and this square is 8. Now 9 is purple. So that means this square becomes orange, which makes that square 8 and that square 7 by the power of Grayskull. That's okay, so that's 7, and that's 2, which means these squares are not 2. Now if that's not 2, that's not 6. And now, bobbins, I was thinking maybe we could prove that this wasn't purple. But actually it's perfectly possible, isn't it, for those two digits to add up to this one. So that's not the way to do that. So what do we do next? I'm looking. I'm trying to spot what we do next. Okay, what are these squares? So this congregation of digits are 1, 2, 3, 4, and 7 again, and we know those are not 7. In fact, we know that's not 7. Do we know that this one? Ah, okay, so this one works differently to some of the others, because this is an 8 arrow. The 7's been pushed up here. So this is a 1, 7 pair. And that means that's not 1. It means this is a 2, 3, 4 triple. That does give us a 1, 2, 3, 4 quadruple in row 2, which means 5 and 6 are a pair in the remaining cells. Oh, it's close, isn't it? Oh, I thought there might be something we could do in column 7, but apparently there isn't. Right. So what, if anything, does this mean? Do I now know? I know this has to be different from this. That's true. Oh, come on, Simon. This must be done now. What's going on in this column? So we need 1s, 2s, 3s, and 4s into these squares. But that doesn't seem to be enough. I think I just need to get either this one or this one, and it'll be happy days. We'll be able to finish the puzzle off. We could do... I don't know. Do I know? Oh, this is tricky. This is still tricky. What's it going to be? It's going to be something to do with... Do I know what this is? This is 2 digits that add up to 9, and it's not 4, 5, and it's not 1, 8, because I know one of these is an 8. So it's either 2, 7 or 3, 6. But it's not 3, 6, is it? Because if it was 3, 6, that would have no fill, because that's either 3, 5 or 2, 6. Good grief. Right, so this is not 3, 6. This is 2, 7, which means that's not 7. Now, does that do anything? Yes. Okay, so this is not 2, 6 anymore. So this is 3, 5. And we know, right, so we might be away now. Because if this is 3, 5, these squares don't include 3 and 5. So they are 1, 2, and 6 now. Ah, but that is a 1. Right, so 1, 6, 2 get placed. This is 3. This is 2. That's not a 2. We've got a chance of a 3 in the corner. And, okay, and in this row, we've not put 6 in at all, have we? So 6 has to go here. We know this is different to the 3, 5 pair, so this has become 2, oh, whoopsie. This has become 2, 6. Let's take 2 and 6 out of these. It loses its ability to be 2. So we get a 1, 3, 5 triple. This square is 1, 3, or 5 by Sudoku. And hopefully now we might be able to do something. Right, these squares are don't involve 3 anymore. So this is a 1, 4 pair. This arrow, do we know enough about this yet? Oh, please. It's still being recalcitrant. I don't believe it. I'm plodding my way through this. I'm going to be... Well, I hope you're going to be kind in the comments to me. I don't know what's wrong with my brain today. Or maybe this is a hard puzzle. It is possible that it's hard. You know, I don't know. I don't know. I'm getting to grips with it, but only very slowly. What else could we do at this point, do you think? This is... Do I know that these squares are 1, 3, 4, 5? They definitely include 5. Look, so this is definitely not 5. There's definitely a 5 in here. These are adding up to at least 13. So this can't be a 1. Ah, that might be important. Because 12, this is clearly adding up to more than 12. I mean, if this was 9, 6, that would be what? 15. That could still work, actually. If that's 8... Oh, I don't know. What about... No, that doesn't work either. My second thought didn't work. What about... I don't know. Oh, Simon, come on. Pull yourself together, man. What's wrong with you? 2. There's an X-wing on 2s, look. So 2 in this column is down here in one of those 2 squares. Can I do anything with that? Of course not. Can I... This is a 9 arrow. It nearly doesn't have 2 on it, but it could have a 2 here. If it doesn't have 2 on it, it would have to be 1, 3, 5. Is there a reason this can't be 1, 3, 5? I don't think so. Oh, where's 7 in this column? It's got to go at the bottom. That's got to be a 7 by Sudoku. Does that do something for us? Goodness, okay, yes it does. Where is 2 in this column now? It's got to be here. That's good. Okay, that is good. So now I get 2 into this square. So there is a 2 on this 9 arrow. So this is either a 2, 3, 4 or a 1, 2, 6. It's one of those 2 things. And can we work out which? Oh, no. Of course we can't. Okay, this square is 1, 4, or 5 by Sudoku. And the minimum sum of these 2 digits is 5. If this was a 1, 4 pair, this would be 5. So this is at least 5. So it's 5, 6, or 7. Oh, sorry, look, we've got a 1, 4 pair here. So that's a 3. That's quite good. Okay, that's doing things. That is actually, that's really doing things. That's suddenly opened up a little bit of... Yeah, this... Ah! Oh, that's very much done things. That's 3 in the corner. That's 3 in the spotlight, losing its religion. Ah, very cool. Yeah, okay, now I get a 4, 5 pair here. So has that really helped us, or just a little bit helped us? These are 4, 5, and 6. That's definitely not 6. The 3 is doing work. That's 3, that's 5. So that's 5, that's 6, that's 4. It really has. That has blown things open. Although we've got loads of pairs, I don't think... Oh, we can do the maths. That's what this line's for, look. We've got... This needs to be an 8. Because I think we've got 14 there. So that's 8, which means that's 8, which means this is 4 at long last. So that loses... Oh, hang on. This being a 3 has done things to this line. This has got to be a 1, 6 pair. So that is not 6. In fact, that is 6. That's 5. And these squares are now 3 and 4, which means this is 5, this is 4. Suddenly it's filling itself in. I'm not doing anything clever here at all. That's a 9. Let's get the colouring right. So we need that one to be that. We need that one to be that. 9 is now going to go in exactly this square. So that's a bit of a result as well. And we've got 9 matching off. So this digit, which is the sum, this digit is the sum of these two, is either 4 or 6. And it's not 6, so that is 4. Which means that's 3 by maths. So 3, 5, 5, 6. That's a 6 by Sudoku. So this has got to be higher. So that's got to be 7. That's got to be 1. 1, 7, 7, 2, 2, 4, 4, 3. Okay, well that's a bit better. This is 7. This is 2. That square ought to be gettable. That's 5, 5, 3, 3, 1, 1, 6, 6, 2, and 1, 4. Goodness me, that was a struggle. It was a brilliant puzzle. I mean, it's a brilliant puzzle. It just outfoxed me completely. I couldn't see what was going on. I couldn't see the ocean for the trees. It was it's really good. It's really good. But sometimes yeah, sometimes it is, you know, we are live solving every day. We don't therefore, I'm afraid, always produce perfect solves, and we don't always see things in the order that we wish we did. If we did that, we would be much higher to being the top of the world Sudoku tree, and we're definitely not that. But I think we do, in the end, tend to find our way through these things logically. It's a great puzzle, Florian. I'm sorry I couldn't get it done with more alacrity. It was just fascinating. It was really difficult in the first place to even, for me, to prove that what was the first colours we had? Or to prove purple wasn't orange was a struggle, but I did eventually get that done. And then, well, at that stage was beautiful, but it's very hard to notice that this arrow and this arrow, or these line segments here, had to be different. And then there was just a whole load of Sudoku shenanigans that proved completely beyond me. Let me know in the comments how you get on. I enjoy the comments, especially when they're kind. Especially. And we'll be back later with another edition of Cracking the Cryptic.